morning, everybody. Mike Mansell from Electro-Matic. I'm the sales manager here in Ohio. Wanted to thank everybody for joining us this morning. We're going to go ahead and get started. Still waiting on a few others to join. Hopefully it will, or they'll be able to trickle in here during this. I wanted to thank Festo and Pneumata and his team, Jim LeDuc and Flavio Lupi, for putting this on today, and the support of Michelle Werner and Amy Teletke on the Electro-Matic side. This presentation will be recorded and you can view it again at a later time as well. So thank you everybody for joining and look forward to this.
Good morning, everyone. So my name is Flavio Lupi, as just Mike mentioned. So I'm a specialist in electric and electronic products with Festo. So we're gonna go over our new product, the Simplified Motion Series today. What that means, so we got the simplicity of the pneumatic actuation. Getting all the benefits with the electrical. So we're gonna see in just 2 minutes a good explanation in a short video that I have here that I'm gonna show you guys what that means. So let's get started.
Flavio, unmute your mic. Up on the top. Top of the screen, next to your camera, you can unmute your mic manually that way. There you
go.
Yep.
All right, thanks, Pete. Sorry about that. So what I was telling you guys is just that video gave us a good explanation about this product, and we put together this presentation to be very short and simple because we're gonna have Jim LeDuc to go over with a hands-on unit with our demo case. So what do we have in the Simplified Motion Series? So as you can see in this graphic here, so it's pretty simple for all the applications that you can use as a pneumatic. We're gonna have the simplified motion to use on the same way, but instead of having air to supply to your unit, you're gonna have the electric just to control on the same way that you're controlling your pneumatic application. But if you need to go over and and you need more complexity solutions like going over to a multi-axis solution with a robotic controller, we can have a good solution for you as well. So what we have in this line, I think you guys saw in that video a linear solution in that case. But as you can see, we've been releasing this product, I mean, in the past years, and we are still releasing new products. So as you can see here, we came up with the new actuator the last year, and the end of the last year. This new version here, it's a kind of a rod style, like, but it's very short. And also we have like ball screws version, foot belt versions, and also a rotary unit that you can easily use it. Sorry. So how are we going to control that drive? I mean, that we have in this motor. The control of that solution is going to be in 2 digital inputs to control the same way that you're going to control your pneumatic, controlling the coils with your valve. You're going to control this solution, and you're going to get like 2 digital outputs as a feedback from the actuator on the same way that you're getting with your limit switch in a pneumatic version. So you don't need to configure anything. The teach buttons that we have here and the little HMI, you're going to configure the actuator easily. And also we have IO link. Talk about specifically about one product. I mean, I'm going to go over just one version here to give you guys an idea what we can get with this product. So let's talk about a spindle axis here that we have in a ball screw version, ELGS. So we can go up to 800 millimeters. The payload that we can handle in a horizontal position is going to be 20 kilos, and a vertical it's going to be 13 kilos. Maximum force 200 newtons, and the maximum speed is going to be 250 millimeters per second. So with these families, we have like just the end-to-end positions, and also we can have the force mode. Okay, Jim's going to go over that as well. So the way that we are controlling that motor, we have the drive embedded on this motor. The way that we designed that product, as you can see here in this picture, we have the drive embedded on the motor, and also we have the encoder as a feedback for our system. We have an absolute single turn encoder to get the feedback and have this closed loop solution for you. The way that you're gonna wire this motor, it's very simple. We have 2 M12 connectors, one 8 pins that you're gonna be for your logic signals, and the 4 pins gonna be for the power supply. So we're gonna get with this product just 3 part numbers, the product and more 2 cables, and that's it. And the way that you're gonna find that, the way that you can size it, it's pretty easy. You can go to our site, festo.com/SMS, and you're going to see our software there. The only thing that you need to use or to fill in that software, it's the data from your application. How much load you're going to handle, like all the stroke that you need, it's a linear rotor application. So all the data that you have from your application, the software is going to come up with all the solutions that you could use, all the products that we have in this specific line that you could use into your solution, okay? And the message in this slide here is just to show you guys, whatever you have like a pneumatic actuator, of course, into that limits, you can easily use this product. And for sure, you're gonna have more benefits and diagnosis from this solution, okay? So I'm gonna pass that to Jim now, and Jim's gonna take control from here. Thanks, guys.
Thanks, Flavio. Can everybody hear me okay?
A little bit louder, Jim.
A
Yep.
little bit louder?
Yes.
Is that better?
Yeah.
Okay. I'm going to demonstrate 2 different types of control with these products. If you can see it as the camera, I have a rotary actuator here, which is our ERMS. And then I also have the one that Flavio had highlighted in an earlier slide, the ELGS, which is a ball screw slide unit. Now I'm going to control this one just with the IO with the switches here on the switch box to simulate the PLC. Setup is done here with the little HMI we have here. We have the status LED, which I'll go over that a little bit later. And then we have 2 arrow buttons and an edit button. Inside this setup, there's different, you can control the speed in, the speed out, the force, the reference, the start press, and the demo. And you'll see that as I start to go through this, you'll see how this little HMI interacts with you. I'm also going to point out that I have our little CDSU USB IO-Link master connected to the ELGS. I'm going to do that following the demonstration on the ERMS. So basically how we would go about it to get into the system is we would hold the edit button here on the side. Can everybody see my camera okay?
Yes, we can see it.
Okay.
Yes, Jim.
Just want to make sure. Make it a little bit bigger here for you. That'll simplify things here. So I'll hold the edit button. It'll get me into the menu. You could see now the little category light here, this LED is on, which is letting me know that I'm in the speed out menu. Now at this point, I can scroll through those menus just to see exactly what I have. And this is an intensity bar here. There's 5 LEDs in here. So if I wanted to change the speed, for example, right now it's showing that I'm at full speed. You could see the little negative on this side and the positive on this side. If you can't see that in the camera, you could see that from the PowerPoint that's still up on the screen. I get back in here. It times out after 30 seconds, so just bear with me. Okay, so I'm back in here. Now I want to edit it. Once I hit the edit button that I'm on there, I'm getting a flashing light. So now I can change these in increments basically of 10%. You could see those LEDs they're a little dim, so this would be like 50%, for example. And then once it's full bright, that's 60%. And I get back out of that speed menu. I can go into this one, hit the button here, and I'm just going to slow this one down. We're not using the force at the moment, so the force is at 100%. The reference is showing which end is what's considered in, the reference end, and then the out would be the positive end. We're not doing a start press function on this one, so I'm not going to demonstrate that one. And the demo button's kind of nice because if you don't have your PLC set up, you can go into this and you can hit the demo mode. You'll notice that the LED on the intensity bar is in the center. And as I move it, it'll move to the different positions and correspond, the shaft will do as commanded. And you can also see over here on the switch box, my status LEDs that are corresponding. So my negative position, so right now I'm in the in position as the negative. And then this goes to the out position as the positive. And then if I want to get out of here and I want to test out my PLC, I can just go ahead and hold this button for about 5 seconds. And it'll get me back out of that. And now it'll pay attention to the buttons. So now I can click the switches, simulating the PLC, and do the movements that we've programmed on the HMI. One thing I will point out, the input buttons need to remain on for the duration of the move. If you just basically pulse them, it'll keep going until it hits the end position. And another nice feature is you can turn both on, and then you can move the actuator freely. As you can see, I'm rotating this by hand. So it basically disables it. Okay, there we go. We're back to good. It's like I touched the cable there and it killed the power on. So just bear with me for 1 second here while I reset that error.
And so, Jim, when you cut the power, that made it go through and do a reference on its first move, correct? So that's why it was a slow mover?
That is correct.
Okay.
Plus, once you turn it on, it has to do its little wake-up routine that all IO-like devices do before it'll allow itself to be controlled, if you will. Okay, so I'm going to skip to this slide here. This is the movement here that we just did. Just a simple trap move back and forth, A to B. That's just simple through the HMI. So no need for any programming. You can do everything right on the little keypad. What I'm going to do now is I'm going to share another tool with you to show some of the advanced functionality that we can also do with this. We have this little unit here, the CDSU, which I mentioned earlier. And then we have the software that goes along with that. And what I'm going to do here, this is just outlining the motion profile. So I'm basically going to wrap it in to a position, and then I'm going to put myself in force mode and start to a clamping function until I hit either an obstruction or the end of the stroke.
And just to mention, Jim, so you're going to go over through IO-Link now, but you guys can program that and set up these parameters through the little HMI as well for this function, okay?
I'm going to get out my trusty little racquetball so you can see that I can change the forces. Basically what I have is the slide unit here with the two little brackets up here and then a stop for the ball. And this is what I'm showing here is the first screen, the identify screen of the CDSU tool, the software. If you have an online connection, you can, once you connect up to the device, it will find the device variant. What I'll point out here is that that's not doing this. This is an early demo and they didn't configure the motor unit properly. So this is showing the ID of just the motor unit, which is not available separately. It is only sold with an actuator connected. Or you could manually download the IODD file. And I'm going to go into this little specialist area, which is where the information is. You can get your process input and output data here. And then you can also control parameters that you would be able to control over IO-Link. There's an identification area, which tells you the manufacturers, your usual IO-Link data, firmware version, hardware version. And then the actual controls are here. So what I'm going to do is I'm going to put my force here at just a real minimal value, 10%. And I have to write that over. And you see it takes it here. Change this 100 to 10%. And now I'm going to go ahead and execute. And this is probably going to run our homing routine since the power was killed. So where is it actually going to work? Okay, as you see, it didn't hit the ball, did it? But if we go down here to the monitoring area, you could see that I'm actually at my 10 newtons, and I am just past my position where I wanted to start press, which was 60 millimeters. Basically what's going on here is the friction in this particular ball screw got me to the 10% mark. So what I'll do is I'll move that back. I'm going to change this to 20%. And then now I'm going to go ahead and execute the same move. And you'll see now that I can cradle my ball. Not a lot of force there. I can still wiggle the ball. But there is a little bit of compression there. Let's see if we can grab a hold of it a little bit more here. I'm going to go up to 60%. And you notice it's crushing the ball a little bit more now. It's got a good firm hold on it. If I go down here to the monitoring area, you can see that I'm at 60 newtons. Roughly, there's a little bit of dithering there. But you can see that my position is a little bit different, because it starts the press at the 60, and it's at 84 now. So it's compressing the ball more than it was. Now I'm going to go ahead and just crank it all the way up here. Don't try this at home. Now you can see it's really got a hold of the ball. You might even be able to see some deflection in the aluminum plate that I have here. We can go down to the bottom. We're monitoring the force here. I'm at 100 newtons. And as you can see, my position incremented by about 6 more millimeters. There's some other information that's also available in here. It keeps track of errors, if there happens to be any. And then there's an event tab where you can see the last errors, and I'm going to simulate an error here for you. I'm just going to go ahead and kill this power. You see an error just popped up. Go back to specialist. It's going to tell me that I have a general malfunction, and it's going to tell me what it is. Or we could go back to the event area, and you can see that I have the supply voltage area, and this is that 1802H. Remember that. Skip back here just for a second. We have charts available, so there's diagnostic information that you can grab just from the little HMI on the unit, the status LED. It is going to give you different LEDs lit up in a sequence or a code, if you will, that represent the error, as you'll notice on that actuator right now. Can you guys see my ELGS pretty good? The light's on there?
It's small, but we can see it.
Yeah, I'll make it a little bigger here.
Yep.
Is that better?
Yes.
Okay, so you could see following this, and I did that on the left side on purpose because this is the chart that I want to use. I've got 5 of these LEDs on. So here's the code for the 5. And then there's 2 in the intensity bar, which happen to be these 2. And then here is your error, your 1802. Power supply voltage, low or not connected or off in this case. So you can do diagnostics that way, or there's also status LEDs on the side that give you some indication of what possibly could be happening. So here's your little indication of the HMI on the side, the push buttons. You know, you have a green LED, and it gives you some diagnostic information, a yellow LED, some diagnostic information, and of course the errors. And that's about all I have. If anybody has any questions.
Hey, Jim, go back to your IO link page.
Okay. Which one, Pete?
Your communication with the ELGS.
Communication?
Yeah, your IO link communication directly with the ELGS, not the PowerPoint, but yes. So go to your specialist.
Mm-hmm.
So a couple things I wanted to point out was the things that you're also keeping track of. So on that screen where you're at right now, number of cycles total, mileage total. So it keeps track of the usage of the particular unit itself. It also keeps track of some of the information in regards to temperatures and different things. Also above in regards to your adjustments in regards to your speeds. So within the IO link, you have a lot of flexibility in regards to seeing what you're doing, but quick adjustability as well, depending on what your application takes.
And as you can see too, there's these variables here are lighting up green. And basically what that means is that as they change, it's just indicating that it has changed from the last state.
The other thing I'd like to just mention is, like Flavio talked about in the beginning of the presentation, by going to the online tools that Festo has, you can very quickly, just by giving information in regards to your application, what your stroke is, if it's in a horizontal plane or vertical plane, in regards to if you have any kind of force requirements, your load, speed, stuff like that. It really allows you to be able to pull out some information in regards to what you could do with Electro-Matic for kind of narrowing down the product that's best suited for the application that you're looking at. Obviously, there's some changes if needed in regards to what you want out of the application, but it really helps you kind of zero in on the products that would best fit it, especially if you're looking at any kind of load requirements or force requirements with a ball screw compared to a belt, or which product stroke-wise and load-wise would be your best fit. So there's a lot of different tools that you can have very quickly accessible from our website that allow you to really narrow down the things that you're looking for and really drive it to the product that best fits what you're looking at.
Yeah, as always, they are all free, okay?
Yes, all our tools are available to customers. Mm-hmm.
Are there any questions? I didn't see anything in the chat, so I just wanted to make sure if there were any questions.
Well, thank you everybody for joining us today. And like I said, if there was somebody within your organization that did miss this and you'd like them to catch it again, it will be available on the Electro-Matic website in the coming weeks. We also are available, any of the account managers, Pete Amata, set up a Teams call or an in-person visit. We do have one of these demo units available in our office in Solon that we can come through and show it to you guys in more depth and or more application-specific requirements. So I want to thank everybody for your time and have a wonderful day.
Thank you.
Thank you, guys.
Thank you, guys.
Thanks,
Thanks,
everybody.
Have a nice day.